So here's a quick description of how an LED works, which is necessary for you to answer the graphing question on this week's assignment. Now, what happens is these electrons is they fall, and as they fall, they lose energy, and that amount of energy they lose is related to the voltage that electron actually requires to be kind of re-excited. So when we think about those electrons, there's a change in energy, and that change in energy is the voltage times the charge. So we have a certain voltage times the charge on the electron that changes the energy of those electrons. Now, if we think about where EMR comes from accelerating charges. So as those electrons fall, so they change their energy according to VQ, and the energy that they lose is emitted as a photon. So this is a white LED, which emits a whole bunch of different colored photons depending on the amount of energy change of the electron. And then our eye sees it as white light. However, in our experiment, we were looking at red, green, blue. It's just a more specific energy change to get that color of light. But as that electron falls, so there's a change in energy here. So there's a change in energy between that level, and that energy produces this photon that's emitted. Now this photon has a specific energy. It's the same as that change in energy. Whenever we calculate the energy of a photon, that's equal to HF. So my change in energy is equal to VQ, which is equal to HF, the energy of the photon. So to answer the graphing question this week, we have the change in energy of the electron is equal to the energy of the photon. And our goal this week is to use that graph that you have available to you using last week's data, as well as the measured voltage, to get an experimental value for Planck's constant.